it's a bird. I'm out hiking right now, and it's a lot of fun. But it is a little bit scary. All of these trees look exactly the same, so I don't really know which way is which. Luckily, I have some tools that can help me make my way back to my campsite once I'm done exploring. Whenever you're out hiking somewhere that it's easy to get lost, or going somewhere new, it's important to know where you are to get where you need to go. We used to rely on stars to navigate, using the North Star to point us north. But stars move, so that wasn't the most reliable system. Over time, engineers have created lots of tools to help us navigate. With maps, compasses, and GPS systems, navigating is much easier today than it was 100 years ago. Hi, I'm Annika, a second-year student studying creative technology and design at CU Boulder. Today, let's explore some of the vital tools for exploration and learn the basics of navigation. There are lots of ways we can describe where we are. For example, let's say you're trying to meet a friend at a park. You can tell your friend that the park is next to your house and near school. While these descriptions give your friend a general idea of where to look, they don't tell your friend exactly where the park is. We can get a little more specific about location by using the cardinal directions: north, east, south, and west. When we look at a map or globe, north is up or towards the North Pole, south is down or toward the South Pole, east is right, and west is left. Where each of these directions are stays the same even as you spin around. So, if the park is here relative to your house and school, you can say that the park is south of your house and west of school. That makes it a lot easier for your friend to find the park. Oh, and look at that! Without even realizing it, we've drawn a basic map. Maps are a great way to communicate where things are. But to communicate location, we first must communicate what the things on the map are meant to represent. We do this by using a set of common symbols for all maps. For example, stars represent capital cities, blue lines represent rivers, and red plus signs usually represent hospitals. We also use labels to say what things are, like city names or street names. And we use this thing called a key to show the viewer what symbols represent what. And this makes it possible to tell your friend that the park is south of your house and west of school, because they actually know what represents your house and school on the map. So far, we've been talking about relative location, or where something is relative to something else. There's also something called absolute location, where we give each point on Earth a label using some kind of system. Street addresses are absolute locations. There's only one 101 TeachEngineering road in small town big state, which makes it much easier to locate than trying to describe it with relative location. So, when we're describing something with relative location, the person we're talking to already needs to know where the thing we're comparing location to is. When we're describing something with absolute location and using street addresses, it's much easier for them to look up via a map. But what if there were multiple streets with the same name? And what if we wanted to communicate a location to someone that doesn't use the same language we do? Well, that's why engineers developed longitude and latitude. Look at this map here. See the lines making a grid across the map? Those are latitude and longitude lines, which we measure in degrees. Latitude lines stretch from east to west in rings along the Earth, kind of like the rungs of a ladder. These are also sometimes called parallels, as latitude lines are all parallel to each other and thus never meet. These lines tell you how far north or south something is from the equator, which is the line that goes around the center of the Earth. The equator is 0 degrees, and the north and south poles are each 90 degrees. Longitude lines stretch from the North Pole to the South Pole and tell you how far east or west something is. We also call these meridians, and unlike latitude lines which never meet, every longitude line meets at both the North and South Pole. Longitude lines measure from the prime meridian, which is the longitude line that runs through Greenwich, England. The line on the opposite side of the planet, which is sometimes called the 180th meridian or the anti-meridian, represents both 180 degrees east and 180 degrees west. Once you pass 180 degrees on one, instead of continuing to count upward, you instead count downward from the other direction. So instead of saying 181 degrees east, you'd say 179 degrees west. We write our latitude and longitude as a coordinate, with latitude first. When we write our numbers, we can either use positive numbers and indicate the direction with a letter, or we can use positive numbers to indicate north and east, and negative numbers to indicate south and west. So, if we were writing the coordinates of Boulder, Colorado, we could either write 40 degrees north, 105 degrees west, or 40 degrees, negative 105 degrees. When it comes to getting even more specific numbers, there's also two ways to do that. The first option is to simply use decimals and end up with a long, super specific number like these ones. The other option is to use minutes and seconds. These minutes and seconds don't measure time like those on a clock, but do divide up similarly. 1 degree divides into 60 minutes, and 1 minute divides into 60 seconds. We write them like this, using an apostrophe for minutes and a quotation mark for seconds. When measuring this way, 1 second of latitude is about 30 meters, or 3 school buses. Since the distance between longitude lines changes depending on how close you are to a pole, the distance a second of longitude covers varies. So, using the coordinate system defined by latitude and longitude can give people a very specific idea of where you are. And these coordinates are very reliable for communicating where you are to other people, as while there could be multiple parks near a school or multiple TeachEngineering roads in the world, there's only one place that is 40.0190 degrees north, 105.2747 degrees west. But when it comes to navigating, there's another important tool we need to be able to use, and it's called a compass. We've talked about the Earth's poles already, but those aren't the only poles the Earth has. We've been talking about the geographic North and South poles, which are the points that the Earth's axis of rotation intersects with its surface. We also refer to these as true north and true south. However, Earth also has two geomagnetic poles. Earth is surrounded by a magnetic field that flows from south to north, and we call where the field intersects with the Earth's surface the geomagnetic poles. However, the Earth's magnetic field moves around, and thus so do the geomagnetic poles. Currently, the geomagnetic North Pole is about 11 degrees away from the geographic North Pole, but over time, geomagnetic north will drift closer and farther away. While they aren't in the exact same place, for our navigation purposes, we can usually treat geomagnetic north as true north. Thus, measuring geomagnetic north would tell us roughly where true north is. And that's where compasses come in. The needle in a compass is magnetized so that one side always points toward geomagnetic north. Since the other cardinal directions always point the same way relative to one another, if you know where north is, you know where east, south, and west are too. And when you combine that knowledge with a map, you can find your way around. It is still important to remember that, depending on where you are on Earth compared to the geomagnetic North Pole, there may be a difference between where your compass points and where true north is. That difference is called the declination. But nowadays, thanks to engineers, We have even fancier technology than compasses and maps. We have something called GPS, which stands for Global Positioning System. Essentially, there are a bunch of satellites orbiting Earth that broadcast signals. When you activate some sort of a GPS receiver, that device receives the signals from the satellites and can then determine where you are. When GPS is combined with a map, such as with the maps on our phones, our technology can do the work for us and figure out where we are and where we need to go. Let's review what we've learned today. There are two ways to describe something's location. Relative location, which is where something is relative to something else, and absolute location, where we label each location on Earth with some kind of system. One of those systems is the coordinate system, where latitude tells you how far north or south something is from the equator, and longitude tells you how far east or west something is from the prime meridian. When it comes to finding your own way around, you can use a compass to know where north is, or use a GPS to pinpoint where you are. And look at that! You now know all you need to know about the basics of navigation. I'm going to go back to birdwatching. See you again soon, and until then, keep on exploring the world of engineering. Check out the full lesson on TeachEngineering, then use what you learned in the associated activities, nitty-gritty using grids and coordinates, northward ho, create and use simple compasses, and find your own direction.